Hi folks, welcome to the first lecture of the Maths for Science 3 module. So in this lecture we're really just going to review some of the skills that we learnt in Maths 1 and Maths 2 and that we'll need to use in this module. So first we'll just take a look at powers. Well, we'll start with significant figures, then we move on to powers, which will kind of be calling exponents from now on. It's a more scientific term. And we'll also take a look at scientific notation. I'm sure these words bring great joy to your heart. So first we take a look at significant figures. I'm not going to cover decimal places. I think most people are okay with decimal places. Sig fig, as they're often called, generally cause confusion when you're encountered by science students. So we're just talking about rounding up. If the next value is greater than 5 or greater, we round up. So with significant figures, it's really establishing the starting point. Where do I start counting? With decimal places, we used to start at the decimal point. It was fairly straightforward. Count out the required number of places, look to the next value, and determine whether we round up or not. With significant figures, it's different. We start counting at the first number that's not a zero, the first non-zero digit. So here we have a number 3058.5, sorry, just to be precise. Now this value to one significant figure, there's our first significant figure. It's the first non-zero digit. We look to the next value, so we don't round up. And now guys, so our first significant figure is 3, but we must preserve the value. Our initial value is in the thousands. Our adjusted value must also be in the thousands. So have a go at this one, to one significant figure. Again, it's the same sequence of digits. 3 is the first significant figure. We don't round up, so to one significant figure, it's 30. 4.98 to one significant figure. There's our first significant figure. We look over, so that requires that we round up. Don't write 5.0. 5.0 would be two significant figures. Simply just 5. And here, again, our first significant figure is 4. We're going to round up, but we must preserve the value. The decimal point must stay in the same place. And there's our answer there. So I hope that kind of reminds you. Make sure you maintain the order of magnitude. So just have a go now at this one. To one significant figure. So pause the video, have a go at that. I'll just keep going. You guys hopefully have unpaused after attempting it. So to one significant figure, guys, it's simply going to be 3. To two significant figures, we count out our two significant figures. We look over, it's going to be 3.1. To 3 significant figures, there's our 3 significant figures. We look over, the next value is greater than 5, so the 5 is rounded up. And there's our value to 3 significant figures. So now have a go at this one again, to 1, 2, and 3 significant figures. To one significant figure, again, we round up, make sure we preserve the order of magnitude. To 2 significant figures, now again, sorry, that's in the wrong place. We'll round up. 49, the 9 gets rounded up to 10, so the 49 gets rounded up to 50. So we still express it, guys. The two values mathematically are the same. They both have the same value, but the second value is accurate to two significant figures. It's letting us know that the next value is not 0.4, it's not 0.54 or anything like that. The three significant figures, it just is as it is. So that's significant figures, guys. You will encounter those in the quizzes and stuff coming, and journals coming down the road. Now we're going to take a look at the summary of the power rules. So anywhere where you see exponent, that's something with a power. If we're multiplying two values, we add the powers. Dividing two values, subtract the lower power from the upper power. Be very careful, guys, if you're dealing with minuses in this kind of a scenario. It's always good practice to write it out. Top power minus the lower power. And that's going to give us a to the power of 4. So watch for that one, guys. That's one that'll trip you up. Anything to the power of 0 is 1. And then we have the 1. This is kind of, I always consider this to be the rule that applies to scientists most. Engineers use it a lot, but scientists definitely use this the most. If a power lives below the line, it can be written in a normal fashion, but with a minus on the power. So what I used to always say is if the power is below the line, bring it up and change the sign. Now we look at examples involving these, and we will definitely be encountering all these rules in the coming weeks. Rule 5, if a power value, and if an exponent is raised to another power, then we multiply the powers. And finally, the square root of a value can be written as a power of a half. So we go, if this is called the language of surds, this is the language of exponents, but these are equal. Similarly, the cube root of a value can be written as a to the power of a third, and occasionally we might come across the fourth root, which is a to the power of a quarter. So now we'll apply these rules. Again, you guys have a go at these, so pause the video and have a wee go. I'll just carry on, but hopefully you will be, this is the best way to learn, guys. It's like we'd be in a lecture. I'd throw this up and you guys would work it out, and then we'd kind of work it out together. So here, first thing I'm going to do, guys, is just acknowledge the square root sign with the power of a half. Now I'm going to work on the top line. Using rule 1, I add the powers. Now we work on the bottom line. Again, guys, I add the powers. Minus 5 plus 2 is 10 to the minus 3. Now, this is where you have to be very careful. This now becomes, using rule 2, top power minus the bottom power. Now the half is still waiting out there. I'll just write it in for mathematical neatness. This now, guys, gives us 10 to the power of 10 inside the brackets. I hope you're okay with that. Double negative. Raised to the power of a half. So finally, guys, using rule 5, we multiply the powers and we get 10 to the power of 5. So I just draw a wee arrow to get that up there. I'll just clear that then, just double checking that I haven't made any errors. Everything looks okay. Now here again, I leave the minus 1 outside. Now working on the top line, add the powers. We're going to get 2 to the power of minus 2. Working on the bottom line, add the powers, 2 to the power of 3. Now we're going to have, again, it's always a good idea, guys, just to write these out carefully. Using rule 2, it's the top power minus the bottom power, and again, no harm to put brackets around the bottom power. Just, it helps catch any potential errors. We've now got 2 to the power of minus 5 raised to the power of minus 1. So our answer there becomes 2 to the power of 5. You'll encounter these in the review Moodle quiz as well, similar ones. Reduce to a single power on A. Looks nasty, guys, but again, just take your time. I'll keep my half outside. So that's always the very last step. So there's no harm in keeping the square root symbol either. Working on the top line, guys, I'm going to have, remember, the square comes in and squares the top and squares the bottom. So we'll have 1 squared, which is still 1. A to the power of 2 raised to the power of 2 gives us a to the power of 4. That's multiplied by a to the power of 6. And again, if I wanted to, guys, I could kind of write it over 1. So now, staying with that top line, I now have a to the power of 6 over a to the power of 4, and that will give me a to the power of 2 on the top, and the half is still hovering outside. So it's always a good idea, guys, just to work your way, keep kind of like a dog with a bone, keep at it until you've resolved it to a single power. Now we'll work on the bottom line. Any a on its own can be just written as a to the power of 1. We use rule 1, we add the powers, be careful. We'll have a to the power of minus 2. Now again, instinctively here, guys, people see the 2 and the minus 2 and they think 0. Be careful. It's a to the power of 2 minus, so it's the top power minus the bottom power. And this is why I say it's always a good idea to put brackets around the bottom power. So that'll give us a to the power of 4. And now the half has kind of been waiting patiently for his turn. We multiply these. Don't ever try and bring the half in, guys, until you've got it down to a single term. And finally now we'll get a to the power of 2. Just double checking everything. It looks okay. So that's our answer to that one. Again, we'll just work on the top line. We multiply these. So first of all, I'll keep my square root. There's the half. On the top line, a to the power of 3 raised to the power of 3. We're going to multiply the powers by a to the power of 6. So that gives me a to the power of 15 on the top. On the bottom, I add my powers. I have a to the minus 3. Now again, a to the 15 minus 3. That'll give me a to the power of 18. And finally, we multiply, using rule 5, we multiply our powers and we get a to the power of 9. So now we'll take a look at scientific notation. Do you remember, it has to be written like this. And if you remember, then I had the little clown face. If the decimal point, if we need to adjust our value, our scientific notation value, either to bring it to a particular millimeter, micrometer, nanometer, or else to bring it back into proper scientific notation form, we often have to adjust the first value, A. So if the decimal point needs to move to the left, we increase the power. If the decimal point needs to move to the right, we decrease the power. So again, this only makes sense when we start to look at examples in context. But if you try and remember that little winking clown and this face here with the wink on the right hand side, it'll help you an awful lot. So have a go at these guys. Just again, pause the video. So this one will be 2.38. And now guys, the decimal point is moving to the left. And it's moving 8 places, so now the decimal point sits here. So there's our scientific notation value. Sorry, so 2.38. Oh, and now, so it was 2.38 by 10 to the power of 8. But the question asks for 2 significant figures. So there's our 2 significant figures. We round up. And there's the correct answer then. Now we have a go with this one. 1.021. Decimal point was here. It's moving 5 places to the left. That's our power. To 2 significant figures. There's our 2 significant figures. We don't round up. So to 2 significant figures, guys, we write 1.0. That's our 2 significant figures by 10 to the power of 5. This one, again, pause the video, have a go. 8.998 by 10 to the power of 3. 2 significant figures, we round up. This will be 9.0. There's my 2 significant figures by 10 to the power of 3. And finally then, 29.8, 2.98. Decimal point only hopped 1 place to the left. To 2 significant figures, I round up. 3.0 by 10 to the power of 1. Now we look at small values, values less than 1. The power must equal the number of jumps the decimal point. Remember the clown face. We're generally going to be using this side of the clown now. The decimal point is going to be hopping to the right. So have a wee go. 6.095. I hope you're okay with that. And now the decimal point hopped 3 places and then 2. So that's 10 to, now it's hopped 5 places, but because it's hopped to the right, we write a 5. And that's our answer there. Finally then to 2 significant figures. There's my 2 significant figures. I look over, I have to round up. So it'll be 6.1 by 10 to the power of minus 5. Again, 2.705. Decimal point needs to move to here. 1, 2, 3, 4, 5, 6, 7. 10 to the minus 7, and finally to two significant figures, 2.7 by 10 to the minus 7. I'll just do this one, guys, in one go. It's going to be 1.3 to two significant figures. Decimal point moves 3 places to the right. And there's my answer. So now we'll just have a quick go at a couple of problems. Now I know you lot will be diving for your calculator, but in the journals, guys, I'd be expecting you to write out your values. We're going to have 2 by 10 to the power of 8 multiplied by 4 by 10 to the power of minus 5. Numbers do what numbers do. 2 by 4 is 8. We multiply the powers. So we add 10 to the power of 8 plus minus 5. So that gives us 10 to the power of 3. And there's my answer. So remember, numbers do what numbers do. 2 by 4. And then powers do what powers do. Here, 2.4 by 10 to the power of 5. And on the bottom then, guys, just, okay, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 by 10 to the power of minus 9. Watch your minuses here. So numbers do what numbers do. 2.4 divided by 3 is 0.8. Powers do what powers do. We have 10 to the power of 5 minus 9. So that gives me 10 to the power of 14. And finally then, guys, I need to write my answer in scientific notation. We can use the clown face. Decimal point needs to hop to the right, so I'm minus 1 on the power. But I also like the idea of balance. This side here gets bigger by a factor of 10. So this side here gets smaller by a factor of 10. Or else we could just use the smiley face. Decimal point moved to the right, so we subtracted 1 from the power. And there's our answer there. So that, guys, kind of covers us for the first, they're the first skills we need to remember. Significant figures, powers, scientific notation. Now we're going to take a look at function manipulation, formula manipulation. Another word for it. So function manipulation requires lots of important algebraic skills. If there's just one subject term, again, these will become more obvious when you look at the examples. What we have to do is use inverse operations in the correct order. So remember, inverse order operations, if we need to kill a plus, we use a minus. If we need to kill a divide, we use multiplied. If we need to get rid of square root, we use squared. If we need to get rid of log, we use 10 to the power of, etc. Sometimes, though, there'll be 2 or more subject terms, double trouble. We do an example of this towards the end as well. In this case, we kind of have a different goal. Our first goal is to gather all the subject terms to one side. Once we've done that, then we can factorize for the subject, and this is how we reduce it from having several terms down to just having one term. And once we've done that, guys, we've now only got one subject term. From there, it's fairly easy. We usually just have to get rid of a bracket, use brackets to surround the bits that aren't the subject. We'd always do that with factorizing anyway. and we use move away the other factor. So we'll take a look again, best explained by example. The words and maths are difficult. So when we're doing this, the correct order, work from the outside in. Remove the furthest terms and operations first. So we'll take a look. So here we're given one of Newton's linear motion functions, and we're asked to make t the subject. So I've just colored t in blue. So he's going to stay on the right hand side, and we need to get rid of that u, and we need to get rid of the a. The u is furthest away, so he's the first to go. That's what I'm saying here. Don't try and get rid of the a first. You need to get rid of the u first. The u is joined on by a plus, which sits here. We don't see it, but it's there. Don't mind that, guys. That's just from a different, an old lecture. That shouldn't be there. So what we do now is we're going to move away that plus u, and how we do it is we subtract u from both sides. So that's what it looks like. We subtract u from both sides, and this is our new line. Now we want to get rid of the a that's joined on by multiplied. So to get rid of it, we divide both sides, and again put brackets around all the left hand side if you want, but everything on the left gets divided by a. And finally then always write your subject on the left. That's it there. So that we've now manipulated the function for t, made t the subject, we've isolated t. There's several different ways of saying it. Here's a slightly more complicated function. Again, there's lots of different values. They all have meaning. We're not interested in that. We're interested in the maths. But we want to make s the subject. So again, I've just colored in s blue. And in a way, this is a nice example because s sits at the end. So that's the first to go. That's the second to go. And it's very similar to the last one. Don't worry about the squares. It actually just moves all in one go. We want to get rid of plus u squared. So it's the plus we're undoing, not the squared. So we subtract u from both sides, because if we square, if we try to get the square root, guys, the u would still be on this side, only everything would now be starting looking very messy. So that's, we just want to get rid of it completely from the right hand side. So we subtract u from both sides. Now the 2a is acting on the s. We want to get rid of that, joined on by multiplication. So we divide both sides by 2a. Finally then, always write the subject on the left. And this is now our manipulated function. So this skill, guys, is very important. We really need to be au fait with this. One more, a little bit more complicated. Here we have the fundamental frequency of a stretched string. Again, we're only interested in the maths, not the application. And we're asked to make t the subject. So isolate t. Again, I've colored it in blue. The furthest thing away from t is all of this. It's joined on by multiplication. So we could divide both sides by 1 over 2l. But remember, when you divide by a fraction, we flip it and we multiply. So really, guys, rather than dividing by the fraction, which you can do, but you're going to have to flip and multiply, so it's nice to do it now. What we really do is we multiply both sides by 2l. Now we want to get rid of the square root symbol. That's the furthest thing away from t now. So to get rid of square root, we square both sides. And again, guys, we square both sides. You don't go in and square each little bit like that. Finally now guys, we have t divided by mu. We want to get rid of mu. It's joined on by division, so we multiply both sides by mu. Finally then, write our subject on the left. And there's our answer there. Double trouble. Sometimes the subject will appear twice or more. So there's a sequence of things to do. Get rid of any fractions, any rational terms to be a little bit more formal by multiplication. Use common denominator if needed. Multiply out any brackets. Gather all the subject terms to one side. That, guys, is really our fundamental goal with these. Gather all the subject terms to one side and everything else to the other side of the equal sign. Use brackets to factorize for our subject. Take, in this case we're looking at x. Take x outside the brackets. And finally then, guys, to get x on its own, doesn't matter what's in the brackets are joined on by multiplication. So to get x on its own, we put brackets around all of this and we divide both sides by that. Finally then, write the function with the subject on the left. So here we have given our equation. Rearrange to make x the subject. So regardless of whatever you think, don't try and cancel the x's, but you know that by now. So here's our steps. Remove any fractions by multiplication. So first step, multiply both sides by 2x. Note 2x by y, I write it as 2xy, everything alphabetical. Now we have this 4x on the right hand side. We're going to bring him over to the left hand side. We're going to subtract 4x from both sides. And now I've highlighted that all the x terms are on the left. So we can factorize for x. In the first term, x is multiplied by 2y. In the second term, x is multiplied by minus 4. Now we've got x on its own. That was our goal. All we have to do now, guys, once you get to here, you're usually just one step from a solution. That bracket is joined on by multiplication. So we're going to divide both sides by whatever's in the bracket. And we get this. Now x is actually on the left. The last thing we could do here, guys, is if it's possible, you try not to have a negative fraction. So I'm going to multiply top and bottom by minus 1. We're preserving the equivalence. We're just changing the appearance. And this is much more mathematically acceptable than this one, because there's less minuses in it. So that, guys, is double trouble. It's a different technique than the one in the previous 3 examples. It's much more your focus is on gathering all the subject terms to one side. This allows you factorize, and that's the crucial step. You go from having several x terms to just having one. And once you get there, you're usually just one step from the solution. So there's just a graph of the function. It's a rational function. It gets that reciprocal looking curve. So that, guys, kind of wraps it up for the review. There'll be a quiz on Moodle. There'll be the first journal will be available, and then we'll have a tutorial as well. So thank you very much for listening, and we'll finish up there.